Welcome again to yet another lesson. This is area of part of circle. Area of part of circle. We are doing area of part of circle. Now, this is basically Form 2. But now Form 3 and 4, good revision. Basic. This is a circle. And in this circle, I'm given the radius. Okay? So I can get the area of this circle, which is pi r squared. So area basically is pi r squared. Now this area in relation to the angle subtended at the center, the angle that is subtended at the center here is 360. So if I relate the angle and the formula for area, then I can say 360 is the angle at the center of a circle whose area is pi r squared. But suppose now I have a small angle here, a just small angle, theta. What will be the area of this sector? Okay? What is the area of the sector? That is called a sector. This is called a sector. We shall learn about segment later, maybe lesson 2 or 3. So this angle here is theta. What area will it represent? You cross multiply. So theta times that divided by this. In short, this is the formula. So if this is 30, I write 30 over 360 times pi r squared. That is part of circle. This is whole circle. This is part. This is a whole circle, but this is part. So I want to know the area of this portion only. That's why I've said theta over 360 times pi r squared. There. Okay? That is something small for you to chew. I want us to concentrate down here. Area of triangle. Let me focus a bit here. Area of triangle. From primary, we know is a half base times height. So this is what we really know. Okay? Then we have number 2, Heron formula. Okay? We have Heron formula. What does it address? If all the 3 sides are known, you use this. Okay? But I want us to focus here because we no longer get right-angled triangle. Okay? We no longer get right-angled triangle. We can be given even isosceles triangles, equilateral triangles. That is where the trick is. So we have to modify it. This one we are used to. This is right angle. So a half base times height. Period. Now I'm talking of a situation like this. For example, you are given an isosceles triangle where PR and PQ are given. Okay? They are given. And this angle is given. So this length is given, this length is given, and this angle is given. Now, this is not a right angle triangle. But what is the basic of a half base times height? It is the height of the highest point from the base you have chosen. Correct? There will always be a base. Then there is a point on that triangle. How high is that point from the base? And when we talk of how high, we deal with a perpendicular distance to the base. Perpendicular distance to the base. So I have dropped here. You can see I have dropped here. Let us say that I've dropped. Okay. So this is the perpendicular height, which makes 90. How do I get this height? We focus down just a bit. Yes, you can focus there. Yeah, think it is on the focus now. Okay, this height. So I'm talking of, in a nutshell, PRL. I'm doing PRL where RL is the vertical height. If I know this side and I know this, I'm looking for H. So I know H, which is opposite, and I know hypotenuse. So I use sine. Sine theta is equal to RL over hypotenuse, which is PR. Remember, what I want is RL. And that RL stands for what? H. If I may put in something like that. RL stands for H. It is the H that I want. So you cross multiply here. PR times sine theta. Now you know PR, you know sine theta. You should be able to get H. Okay? This is simple. Check it from here and understand the definition of the height. We have a half base times height. Base. So there are two letters on the base. Always there will be two letters on the base. Okay? Then what I need is a vertical distance from the third letter of that triangle to the base. So even if I'm given, just check here a bit. If I'm given here a triangle like this, I call it X, Y, Z. And suppose I'm given this is 10. This is 6. And this is 20. Okay? So, look. That is the vertical height. This is my H. But my base is 6. So what do? We focus again down here a bit. I focus down. Yeah, I can use this space. See, H, and I have 10. So I will say sine 20 is equal to H over 10. H is equal to 10 sine 20. So I know H. Therefore, I know I can calculate now. I can calculate the area. Area is equal to a half. My base is 6. And then my height I put 10 sine 20. That is how I will get the area. Okay? Are we done there? Have we focused until the... Yes. That is the right focus there. We can focus, yes, here. From this triangle, this is the height, vertical height. So I use the formula sine 20 is equal to H over 10. Then H is 10 sine 20. My H is 10 sine 20. So when I go to the basic formula, a half base times height, just somewhere here, a half base times height. My base is 6. My height I have found. I now replace down there. I have base height. Base is 6, then my height is 10 sine 20. So you compute this and get the answer. Okay? So what we are saying is get the basic. Next lesson, I'll be applying these basics to explain them more when I put them into application. Fine. Thank you.